One of the things our professors really were impressed with was that there's so many different sciences that we focused on to design this. This is not merely mechanical. You can see in the back it's completely electrically wired. And then David here did all of our programming in a programmable logic controller here in the front. In an effort to design a washing machine for use in space, my team and I have developed a system that uses external agitation as well as a piston press paddle that will squeeze the water out of clothing. This is somewhat different than what you'd normally experience in a commercial washing machine, because although it looks like a standard washing machine, it has a door on the front and you load it from the front. Instead of having an actual drum that's rotating around inside of there, lifting clothing and dropping them back into the water, and you basically stuff it completely full. You don't need any airspace for things to bounce around. You stuff it entirely full of clothing, then it fills with water and detergent. Then a ring cam rotates around that flexible drum and forces these agitator arms to actually massage that drum. This provides enough agitation that you actually can get all of the particles loose from clothing, and it does do some fairly reasonable stain removal. The goal primarily was to focus on water consumption and energy conservation. And what we did here, because it will be in a lunar habitat, the water needs to be recaptured so it can be filtered and reused somewhere else. So what we do, we squeeze out all of the water and then send it back to, right now, this blue plastic drum, which kind of represents their filtration system. We're able to recapture everything except for 1 3/4 gallons of water that remains in the clothing when they're wet. You can imagine wet clothing, actually how much water it retains if you tried to wring it all out. So an entire load will retain that 1 3/4 gallons. However, as far as energy conservation goes, we calculated based on full load current draw, and our machine uses 0.117 kilowatt hours per load of laundry, where highly efficient machines that you could buy today use about 0.34 kilowatt hours per load of laundry. Well, in competing against multiple teams from the University of Texas, Texas A&M, and Rice University, we actually won best team overall, which was a big surprise for us, as well as best model, best poster, best oral presentation, best paper. That was a total of 11 first place awards, plus the best overall and a forum favorite that everyone at the showcase actually voted on.